Okay, we're talking about horizontal and vertical asymptotes. You've seen problems like this before, x over x plus 1, and we were before concerned about what makes them crash. We would say, like, make sure you don't let x be what? Negative 1, because that would make it crash. So the domain of this thing would be all real numbers except you can't let x be negative 1. So you'd draw the thingy like this, and here's negative 1, and you'd say it was like this. And so you could say the word work anywhere up to negative 1, but it would not work there. And then it would start working again after negative 1. What does that look like on a picture? On a picture, that looks like an asymptote. Saying that it doesn't work at negative 1 means there's a line like this at negative 1 that it'll never touch. All right, I'm going to make this a little simpler and just put a 1 on the top. And then I want you to graph that. Grab your graphing calculator and graph. You know what? I'm going to save you time. We don't have time for that. I am going to be your graphing calculator. Watch what happens when you type that in. It goes like this. Okay, the whole graph got shifted 1 to the left. Does that ring a bell? Okay, now this dotted line there, that's an asymptote. That means that it can never touch negative 1. That's the point of saying something like x cannot be negative 1, is because if it was, it'd be on the asymptote line. All right? So when I have a problem like this, 1 over x plus 3, x minus 5, then there's two asymptotes. Because there's two things that would crash the function. Those things are asymptotes. So, if I were to graph it, I know that at x equals negative 3, I can't let it be negative 3, otherwise I'll have an asymptote line there. And x cannot be 5, otherwise it would crash the whole function. That's why there's an asymptote line at 5. So there's one at negative 3, and there's one at 5. There's asymptote lines like that. Okay, so you're going to be given a function like this. Typical problem today, they're going to say x over x minus 5. And they're going to say, where is the horizontal asymptote? And you will say, at x equals 5. That's how you find horizontals. I'm wrong, not horizontals. I think I said the wrong thing from the start. I'm sorry. Vertical. These are the vertical asymptotes. They're up and down lines. Those are vertical lines. I'm sorry. Those are vertical asymptotes, not horizontals. Vertical lines. Okay. So they're vertical lines again, like x equals 5. So I would have a line at x equals 5. Like, let's see, where is the line? Here's the line at x equals 5. Okay. So those are vertical asymptotes. Sorry about that. Now, the horizontal asymptotes is the other thing I need to teach you. And to understand that, you need to understand degree. I'm going to show you a couple simple ones. X squared plus x, and compare that to x cubed minus 5, and compare that to just y equals x plus 7. This one is a function that has degree 2, because it's got a squared in it. This one, take a wild guess. Degree what? Degree 3. What's this guy? Degree 1. What if it doesn't even have an x in it? Y equals 7. What degree do you think that is? Degree 0. It's almost as if it has an x to the 0. You get that? Because if it had had an x, y equals 7x, that would be degree 1. This would be degree 2. Okay, so do you get how to do degree? It's just the biggest exponent that's on there. So if you had one with like a whole bunch of x's, x to the 3rd plus x squared minus x plus 7, that's degree 3. You just pick the biggest one. All right, now, if you have something on the top and something on the bottom, what degree is on the top? Degree 1. What's on the bottom? Degree 1. They're the same on the both, right? That's one of the 3 things. Do you remember learning this last year in higher algebra? There's bigger on top, bigger on bottom, and same on both. If you hadn't learned them last year, you got to write them down now. Bigger on top, bigger on the bottom, or it's the same on both. All right, these are all y equals things. These are all, since they're y equals things, they are lines that go across. These are the horizontal asymptotes. Okay, these are the horizontal asymptotes, and if it's bigger on the bottom is y equals 0 is where your asymptote will be. That means in a picture, y equals 0, the asymptote goes like right here, right on the axis. A horizon line, horizontal. All right, next, what if it's bigger on the top? Then there are no horizontal asymptotes. So, and the last one is the same on both, and that's a ratio. And that would be like this. This one's the same on both, right? It's a ratio of its lead coefficients, the numbers in front. Do you get that there's a 1 right there? Do you get there's a 1 right there? Then the lead coefficients are both 1. And it's a ratio of the lead coefficients. So the answer is y equals the ratio of those two, which is 1 over 1. Which means y equals 1. The asymptote would be at y equals 1. The ratio is often an answer of 1, but it's not always. Okay, so here's another one where it's same on both. Y equals 6x over, or plus 1 over 5x plus 7. First thing you ask yourself, is it bigger on bottom, bigger on top, or same on both? Same on both. If it's same on both, you use the ratio. Ratio of what? The lead coefficient, these numbers. So the answer for this one would be y equals what? 6/5. That's where the line would be. Remember, these are horizontal, kind of like horizon lines. This would be up at 6/5, which is about 1.2. So it would be like a line going like that, except I should make it dotted to show that it's an asymptote line. So this graph would have an asymptote line right there. All right, so sum it all up. Say you had this. 1 over x plus 2, x minus 3. First thing, the vertical asymptotes. Those are x equals things. And it's a lot like the domain. What are the things that would crash this? -2 and 3. So the asymptotes are at -2 and 3. That's verticals. Horizontal asymptotes, Bob will tell you. Is it bigger on bottom? Is it bigger on top, or same on both? What's this one? Bigger on the bottom. And if it's bigger on the bottom, then it's always y equals 0. You don't have to look at what the numbers are. If it's Bob, it's y equals 0. So Bob is a 0. Sounds kind of mean. My dad's name is Bob, so I'm not trying to be mean to Bobs here. All right, Bob is always y equals 0. And another one. All right. Is this bigger on top, bigger on bottom, or same on both? Bigger on top. What's the rule for bots? There are no bots. None. There are no asymptotes. Now, are there asymptotes the other way? Is there anything that will crash this thing? Yeah, so then there probably is an asymptote that way. That's the x equals kind of asymptote. X equals, can you do it in your head? 1/2 is correct. If you couldn't do it in your head, you'd go 2x minus 1 has to equal 0. 2x has to equal 1. X has to equal 1/2. Okay? You just set it equal to 0. All right, so x equals 1/2. That seems important. It is. There's the horizontal and the vertical, and I'm going to be encouraging you to remember it in a dumb way. Vertical. Because that will remind you that it's x's when you're doing the vertical asymptotes. You know what happens all the time on this question? There's two lines. There's the horizontal asymptote and the vertical asymptote. And on a test, we'll ask you for both, and kids will get them screwed up. They'll give me y equals things where they're supposed to be giving me the x equals things. So if you try to remember that it's the vertical and the, what do you think I'm going to say on the other one? Horizontal. You got it. The horizontal and the vertical. You won't screw it up if you can just remember that. Okay, so the horizontal one, that's the horizontal one, that's the y equals thing. And if it's bigger on top, though, there aren't any. So I'd just say y equals none. There aren't any. And then x or the verticals as the zerticals, and those are x equals things. And is there anything? Yeah, there was. What was it? A half. So the horizontals, there weren't any. The verticals, it was a half. All right, one more. 3x to the third plus 2x squared all over 2x to the third minus 7. All right. Oh, that's a nasty one. I got to make it not quite so bad. I'm going to make this squared and then make this squared minus 16. I could definitely see this being a test type question because it's got this little thing in it. We love that. You know why? Because you can factor it. A lot of people don't think about that, but you can factor it. Okay, so then first thing you'd have to do is figure out my vertical and my horizontals. Okay, x are the vertical ones, and those are x equals things. And just look at your equation. It's got x's in it, right? So I got to find the things that would make x. Well, maybe it'd be helpful to factor this thing. What could it factor into? X plus 4 and x minus 4. So I have two danger things, 4 and negative 4. So I have two verticals.
X plus minus 4.
Verticals.
X plus minus 4.
Nope. All right, and last one is the y ones, with their the horizontals. And who tells you why? Bob tells you why. Is this bigger on bottom, bigger on top, or same on both? Same on both. It's the ratio deal. So y equals 3 over, that's a 1. 3 over 1, which is the same as 3. There's your asymptotes. I know that went through it kind of quick, but that covers everything that you have to know. Now let's do a couple off the worksheet. I know we're kind of crunched for time, but believe me, you'd rather have a couple done on this thing when you go home than not have any done and then look at it and go, what did he say again? Of course, you could always watch the video, but I want to pause for a second. I'll hand these out. I'm going to let you skip a couple on here. I'm going to have you skip number 2, number 4, and number 6. Skip 2, 4, and 6. And number 8, you can skip C as in cat. All right, so 2, 4, 6, and 8, C. All right, now let's do number 1 together. It should be an easy one. It's got simple numbers. And we got to find the horizontal, and the vertical asymptotes. I'm telling you, it's going to come in handy. Okay, x over x minus 1. So if this is my function, then I'm looking for the horizontal or the y equals things. And who tells me the y equals things? Bob tells me those. Is this Bob or is this not Bob? This is not bigger on top. This one is same on both. It's same on both. A lot of people think the bottom's bigger. It's not. They both have degree 1. Okay, so it's a sob. It's the same on both. So yeah. And this one, therefore, is a ratio, and so it's y equals what? Good. And then the x kind, those come from the bottom. What would crash the bottom? 1 or negative 1? 1. X equals 1. This is the horizontal, and this is the vertical. The x ones are the vertical asymptotes. Okay? Done with that one. Let's move on to number 3. Number 3, it says x plus 2 over 3 minus x. Half the time it's just trying to figure out, is it bigger on the bottom, bigger on top, or same on both? The x equals thing is the easiest thing. Let's just do that. What would crash this function? And therefore x equals 3 is an asymptote. It's a vertical asymptote. And then the other kind is the horizontal or the horizontal. It's a y thing. And it must be Bob telling me that. Is it bigger on bottom, bigger on top, same on both? Same on both. Now be careful on this one. It's the lead coefficient. That 3 is not a coefficient. There's a 1 here and there's a negative 1 on that one. So it's 1 over negative 1. Okay, so what's y equals 1 over negative 1? Same as y equals negative 1. So there's your two asymptotes. The x and the y, one of them's the vertical and the other's the horizontal. Okay, Let's move on to number 7. 2x minus 4, x squared minus 4. Ooh, I can factor something there. We love that little difference of squares thing. 2x minus 4 over x squared minus 4. Right away I'd factor it. Just don't even start the problem until you got an x plus 2 and x minus 2. Now, I'd ask myself, be careful now. Is it bigger on bottom, bigger on top, or same on both? So Bob will tell you why. You're right, it is bigger on the bottom, because if you multiply that out, it's got an x squared in it, and squared is bigger than a 1. So, degree 2 on the bottom. So, Bob, bigger on bottom, what's the deal with Bob's? Y equals 0. And then the x equals 1, there's actually 2 of them. And they are at 2 and negative 2. And those are the zertical, or the vertical. All right, it's just about time to go, and that's all I got for the video.